This is your part 1 video for 4-5 solving rational equations. And our essential question here, how can you solve rational equations and identify extraneous solutions? So extraneous solutions, we'll have a definition for that before example 3. But basically it's a solution that you get that doesn't actually work whenever you plug it back into the problem. So the first two examples we're going to look at, or this is really part A and B of example 1, we want to know what the solution is to each rational equation. And you can see up above, there's a definition of rational equation. It's an equation that contains some type of rational expression. When you have a fraction equal to a fraction, or even a fraction equal to a number, the easiest way to solve that would be to cross multiply and set your products equal. So I'm going to multiply the top left to bottom right diagonal. I'm going to multiply the top right to bottom left diagonal, and I get 1 equals 2x plus 8. Notice there I did have to distribute the 2 to both the x and to the 4. And then I just go through and solve my equation. So I'm going to subtract 8. I get negative 7 is equal to 2x. Divide by 2, and I get x equals negative 7 halves. Part B is going to be very similar. Again, I'm going to put that 1 in the denominator. If you don't have a denominator, it's understood to be 1. We cross multiply. I get 1 equals 5x minus 15. So 16 is my 5x. X is 16 over 5. So when you do have just a fraction equal to either another fraction or a single number, it is a lot easier to solve than if you have some other type of situation. The next example we're going to look at is a word problem, and these are very, very common and also commonly missed by students, so it is important that you pay attention to the setup here of this. It says Arthur and Cheyenne can paint a wall in 6 hours when working together. Cheyenne works twice as fast as Arthur. How long would it take Cheyenne to paint the wall if she were working alone? So if they can paint the wall together in 6 hours, we want to think about how long it takes them to paint a single wall. So with Arthur, maybe if I could spell Arthur's name correctly. So Arthur, he can paint 1x of a wall in an hour, because it's obviously going to take him longer than an hour. So for example, if it took Arthur 10 hours to paint a wall, he could paint 1/10 in an hour. So 1 over x of a wall in an hour. Cheyenne, she paints twice as fast. So if Arthur paints 1 over x, Cheyenne is going to do 2 times that, so she is 2 over x in an hour. Together, they can paint 1/6 of a wall in an hour. And that's going to be your rational setup. How much Arthur paints plus how much Cheyenne paints is equal to the total that they can do together. Now, luckily with this, and this is why this question comes up now instead of later, both of your fractions here have x in the denominator, so I can go ahead and add those together. I get 3 over x equals 1 over 6. I cross multiply those, and I get x equals 18. So it asked me, how long would it take Cheyenne to paint the wall if she were working alone? Well, 18 hours is how long it would take Arthur. If Cheyenne paints twice as fast, she's going to take half the amount of time. So it would take 9 hours for Cheyenne to paint the wall. And you can see there, if you plug those in, If you plug in the 18, 1/18 plus 2/18 is going to equal 1/6. So your math works out there. So now we have the definition for extraneous solution. The solution that makes the value of your denominator equal to 0, or we're going to be using extraneous solution in chapter 5 as well. Your extraneous solution is something that you do get through algebra. It's a solution that seems like it should work with the math required. However, when you actually go and plug it in, it doesn't work in the problem. Because I am dealing with rational functions here, your extraneous solutions are going to be the ones that you get where if you were to plug them back in, you would get something that's not defined. So how I would suggest solving these types of questions and how I was taught and seems to work out what I think is for the best is you want to find your least common denominator of all of the fractions in your problem, multiply every fraction by that least common denominator. Because I have equations now, what I do to one side, I have to do to the other. And if we multiply by that, the fractions are going to go away, and you're just going to have a regular equation that you have to go through and solve. So I have an x minus 5 and an x minus 3, and then I have this x squared minus x plus 15. Well, luckily, that factors into x minus 3, x minus 5. So my least common denominator is x minus 3 and x minus 5. So I'm going to multiply every single term by x minus 3 and x minus 5. Notice I'm spacing myself out here. And actually, instead of using that format, I'm going to go ahead and use the factored form. You'll be able to see how things simplify a little bit better. So first fraction, x minus 5, x minus 3. Second fraction, x minus 5, x minus 3. Last fraction, x minus 5, x minus 3. Now the reason I couldn't do this in 4-4 is I didn't have equations. We had to do the same thing to the top and to the bottom of our fractions. But now that I have an equation and I'm multiplying, as long as I multiply every term by the same thing, I'm not breaking any math rules. I'm doing something that is completely allowed. And now we can go through and simplify from top to bottom with each individual fraction. So the first fraction here has an x minus 5 in the top and an x minus 5 in the bottom. Those can go away. I'm left with 1 times x minus 3, which is x minus 3. Second fraction, I have an x minus 3 in the top and an x minus 3 in the bottom. So I have x minus 5 times x. I can distribute that. So I'm going to get a plus x squared minus 5x in that new numerator. And then for the fraction on the right-hand side, the x minus 3's divide out, the x minus 5's divide out, and you're left with a 2. Now I have a quadratic equation like I used back in topic 2. So let's rearrange this, combine our like terms, get everything on one side. I'm going to have an x squared. X minus 5x is minus 4x. Subtract over the 2 with the minus 3. That's going to be minus 5. And that equals 0. So I'm going to factor this. Factors into x minus 5, x plus 1. So my solutions that I get are x equals 5 and x equals negative 1. Well, if you look back at the original problem, if I were to plug 5 in to the first fraction, I have 1 over 5 minus 5, which is 1 over 0. That's where your extraneous solution comes in. 5 is not a real solution. It does not work whenever you plug it back into the original problem. Negative 1, however, does work. whenever you plug it back into the original question. So again, we would cross out the 5 because that's extraneous. So the only solution this problem has is x equals -1. That's where I'm going to stop this video. There will be a part 2 video that picks up with example 4. So go back, re-watch this. This can be a little bit tricky the first time that you do it, and reach out to me if you have any questions.